Hey guys, we're going to be starting our new unit on slope. The first thing we need to talk about is direct variation. Um, direct variation, just the word, if we think about it, I know it's a little bit crazy word for math, but direct, if you think about the definition of direct, just straightforward, okay? And variation is, moving up and down. So straightforward, moving up and down. How it applies to math is that what happens here is K is having a direct variation on X or on Y. You happen to have a constant number here, K, and you multiply it by X, and that's going to make a direct variation to Y. Okay, so it's constantly changing. Okay, so if X changes, Y changes by K. All right, so K is always never zero. Okay, it's always a number, and it's a constant variation. So I have some examples of some equations up here that we're going to be using, and we're going to be going back to a linear kind of equation. And here's a sum right here: y equals 3x, y equals negative 2x, y equals 4x, and y equals negative 2x. Okay, we're going to be using that one twice. So what we're going to be doing here is the first thing that direct variation wants you to do is to find the slope, okay? And also find what's happening. Typically, the direct variation and the slope are the same. The constant variation, and the slope are the same. And something with direct variation always goes through the point 0, 0 on a graph, okay? So if you're looking at a graph and you see that it goes through point 0, 0, you can automatically assume it has direct variation. Then also, if it's set up in this form here, y equals kx, or if you can move the equation around at all to make it y equals kx, okay? So we remember from yesterday or today in class, we talked a little bit about the slope equation to help us refresh our minds. You take the second y value and subtract the first one from it to get our rise, and then x2 minus x1 to get our run, and that will give us our slope. You'll find a connection here in a little bit between our k and our slope. All right, so in this question right here, I'm going to ask you to find the constant variation and then also to find the slope, okay? Immediately from this equation, y equals 3x. You know that our constant variation is k, and that equals 3. Okay? Now we have these points 0, 0, and we have this point 1, 3. Okay? Now, since we have those 2 points, we are going to use the slope equation to find the slope. So my y2 is 3, my y1 is 0, my x2 is 1, my x1 is 0. So 3 minus 0 over 3 over 1 minus 0. So that means my slope is 3 over 1, which reduces to 3. Okay? So if we find a connection here that my constant variation is 3 and that my slope is also 3. We'll see if that's a trend here in the future. All right, next one. Y equals negative 2x. We know immediately that our constant variation is negative 2 because it is right there in front of our x. And we need to find the slope in. So our 2 points, 0, 0, and 1, negative 2. All right, our y2 is negative 2. Our y1 is 0. Our x1 is 1, and our x2 is 1, and our x1 is 0. Okay, negative 2 minus 0 is negative 2. 1 minus 0 is 1. So our slope is also negative 2. So we're finding the trend that our constant variation and our slope are typically always the same. Both of these have direct variation because they are going through 0, and k has a direct variation or a constant variation on x to change up y. Okay? Now, You'll also be asked to graph equations that have constant or direct variation. And simply all you do is you look and you say, recognize, okay, this is my constant variation, which is also my slope. Okay? So my slope equals 4. Today we learned in class that slope is always rise over run. Well, 4 is not written in a fraction. Can we write 4 in a fraction? Of course, if we write it as m equals 4 over 1. Okay? So what you're going to do is you're going to start at 0, 0, because we know if it has direct variation, it always goes through 0, 0. So we can start there, and then we can do our rise over run from there. All right? Since we already have it set up like this, 4 is our rise, and 1 is our run. Okay? So we're going to go ahead and go up 4, 1, 2, 3, 4, and over 1. Okay. Now, to be successful at drawing lines on a coordinate plane, you don't necessarily have to have more than 2 points. It's nice to sometimes keep going up from here again and go up 4 over 1, but it's not necessary. So all you need is 2 lines to draw a graph. So we have it there. And that is a graph of our line y equals 4x. Okay? One more. Y equals negative 2x. This one is a little bit different, but use the same concept. Negative 2 is our constant variation, which we also know is our slope, m equals negative 2. You can rewrite negative 2 as a fraction as negative 2 over 1. All right? So that means our rise is negative 2 and our run is a positive 1. If we're rising negative 2, that doesn't mean we're going up. That means we're going down, right? So since it has direct variation, we know it already does. We're going to start at 0, 0. We're going to, instead of rise positive 2, we're going to rise negative 2. 1, 2. And we're running a positive 1, which is to the right. So then that's our point. We can go again. 2 more down and 1 more to the right. Okay? So that is a graph of y equals negative 2x. Okay? If you notice today that we said if it had a slope of negative, or had a negative slope, it slants up into the left. Has a positive slope, it slants up into the right. All right, that is our introduction of direct variation. I hope you took notes because remember, you're a lot more successful if you're writing it at the same time.